You have all these warmth indicators on top, so you got to have cold earth and then a really hot earth for the dolomite. And they're going back and forth with a snowball hot house earth a couple times in the Precambrian, and there's a tremendous debate over this right now. And I think that's a serious enough problem to doubt the whole thing. Also, we have grooves and striations in the Sahara that generally point north. And this is very unlike the way ice sheet, because they will surge and they will form striations almost 180 degrees out on the surges. And yet these are practically all in the same direction going north, which is quite different. So, do we have a mechanism to account for this thing? I believe we do, called huge, gigantic submarine landslides during the flood. We have some analogs in some of these flows. They're called debris flows. Here's one debris flow from the top of the Gravely Range in Montana, which is used to be an Eocene ice age deposit until they realized it was so warm in the Eocene you couldn't have ice ages. And it's, rocks with a finely grained matrix. And it's interesting that you have striated pavements underneath this. Here's the material right here. It scratched the pavement, this bedrock, and almost polished it, and formed striations in two different directions like you'd expect with glaciation. And not only that, you have these fine cracks called chatter marks, which are thought only to be due to glaciation, but yet this is due to a landslide or debris flow. Also, this is some of the, right here, this is some of the debris on it. And here's some of the scratched rock. So I think landslides can account for all these ancient ice age deposits. And I've written it up in a book that you can get down there, an in-depth study, Ancient Ice Ages or Gigantic Submarine Landslides. I'm just giving you quickies on this because these are extensions that I've done in the last few years on the Ice Age model. Now, we have a challenge of ice cores. Recently, they've been doing a lot of drilling of the Greenland and Antarctic ice sheets. So on the Greenland ice cores, they have drilled down to the bottom from the very top, and they claim they can count annual layers to 110,000 years, just like counting the rings in a tree to determine the age of the tree. What do we do about that? Is that true? And just recently, Antarctic Dome Sea Core just recently reached what they believe is 900,000 years. Well, how do they determine that? Is it really that old? So these are challenges, and I've been emailed by people, and I get Answers in Genesis sends me stuff inquiries that they get, and so it's amazing how this has really challenged a number of Christians on what do we do about this? Well, it's not. When I got into it, I found out it really wasn't too difficult. But first of all, let's have a little preliminary. When ice piles up on an ice sheet, one annual layer, which you can detect at the top of the ice sheet due to chemical effects, what's called oxygen isotope ratios, things like this that I'm not going to go into. But one annual layer with time, as it's buried more and more, it squeezes, all sort of like plastic flow, gets stretched out this way and gets thinned. Okay? Now, as you get towards the bottom of the ice sheet, that's a lot of pressure to thin. So how much thinning you do depends on your assumptions. If the ice you believe is old, the thinning will be tremendous. Each annual layer will be paper thin by the time you get down to the bottom. Well, if it mostly piled up during the Ice Age, our annual layers would be 3 to 6 meters thick or more, depending on how much compression we had. So here's the uniformitarian model. It's been in equilibrium for a few million years. This is the Greenland ice sheet, I might add. And the annual layers start out this thick. By the time they get down in here, they're thinner. And by the time you get down to the bottom, they're paper thin. They drill at the top of the ice sheet because supposedly the ice goes straight down. While if you drilled over here, the ice would go out like this, and you'd have flow problems. So in general, at the top of the ice sheet, it should end up going straight down, so there should be few complications from flow. Now we start with no ice at the end of the flood, and it builds up. At the peak of the Ice Age in 500 years, you maybe got half the ice there, and it keeps building as the rest of the ice sheets are melting. And then it keeps building after that for a while until it reaches steady state to the present time. That's our Ice Age model. So the annual layers, this is the annual layers with depth. Here's the depth in the GIPS-2 core. It's 3,000 meters deep, 2 miles deep. The uniformitarian models, we start out about 2.2 meters about 20 centimeters thick of water equivalent of pure ice. In other words, all the snow goes to ice. And with time, their annual layers thin and thin and thin until when you get down a little more than halfway, they're paper thin. Us, on the other hand, this is the Ice Age portion right here. During the Ice Age, it built up rapidly, maybe 6 meters a year. And because of compression, it's gone down to about 3 meters, 2 to 3 meters. There's a break of scale here. This is a schematic only, by the way, to illustrate the drastic contrast. So our annual layers are very much thicker. So why can't they see that the annual layers are thicker and than their thin ones? Well, it's because of what they expect. They expect it to be old and in equilibrium and therefore paper thin, and they don't see it because they don't expect it. And this is a common tendency, not only for lay people, but in scientists also do it. I picked this up by accident because I was a shift worker, worked graveyards, days, swings, tired all the time. I was trying to make things better, so I wrote a book called The Promise of Sleep. And this is just a statement he says in it. He says, even when they are looking, people usually see only what they expect to find, and they do not see what they assume for whatever reason could not exist. This was like the Lake Missoula flood. They couldn't see the evidence for the Lake Missoula flood. They can't see evidence for the biblical flood because of their mindset, their assumptions. And this is why they can't see our thicker annual layers. Here's, this is the first core, the Camp Century core. Now I want to make a point that in these the Greenland ice sheet, you see evidence of only one ice age. Based on, I'm not going to go into this, think of it like this, temperature is cooler to the left. This is the Ice Age ice, compressed. And it started off kind of warmer and cooled with time, exactly how we expect. And then became cool, and then it warmed up pretty fast. And this is the post-Ice Age, its steady state. It only takes 5,000 years, by the way, to account for all the ice on the Greenland ice sheet at the present precipitation rate, I might add. So it's not a problem getting 1,000 meters of ice up there in a very short time in thousands of years. But this is the Ice Age ice right here, greatly compressed. And there's only evidence of one ice age at the Camp Century. And by the way, it's frozen to the bedrock here. So if there's more than one ice age, you should see the evidence down here because it doesn't melt. Now, because they say that it's paper thin, this is the time scale for the Camp Century ice core. They think it's